Welcome back everyone to the Hello World guys. This is another episode of the Raycaster in C++ series, and in this video we are going to add a sky to our game. So without further ado, let's jump right into it. So here inside of my project directory, I'm going to go ahead and I have already implemented the sky functionality, and I will go over the code step by step and so that you can understand what we are doing different here. So first of all, I'm going to open up render.h and render.cvp, since these are the main files that we have modified. Inside of render.h, the only change is that we have added another texture here, so you need to just have another texture for the sky, which I've called sky texture. And this sky texture that I've got is in an image here. As you can see, sky texture.png, we have got an image here. And the most important thing is that this texture needs to be seamless, which means that so that if we scroll the texture, then seams don't appear, because we are going to scroll the texture when the player looks around. So if seams appear, then that would look pretty bad, so we need to make sure that the texture is seamless. Once you have made sure that that texture is seamless, I'm going to go ahead and open up render.cpp now, and inside of this you can see in the init method we are loading the sky texture here, like we are loading all of the other textures, but of course we don't perform the size check because this does not need to be a perfect square. And then we call this set repeated to true function, and we'll understand the purpose of this in a second when we get to actually rendering this. So in here I am going to go down and open up the draw 3D view here, and earlier on we were using a rectangle shape here. I've removed that, and you might be saying that we'll use a sprite for rendering the actual sky, but that's not how we'll do this. Instead, you can see that this is the main code for our drawing sky. So this is all of the code that we need for the sky drawing, and we'll go over this line by line. So first of all, you can see that we calculate a line offset. Why do we calculate that, and why is this necessary? When we call this x offset, and the reason behind this is that we want to scroll our texture, and we'll revisit this in a second. First of all, you can see that we create a vertex array here called sky. It consists of 4 vertices, and then we just call draw on this and provide it with the correct size, and we also make sure to tell it that we are rendering quad. So this is pretty like simple stuff. So we just have a plain vertex array, not a sprite and not a shape or anything. We just have a plain vertex array and we draw it as sf quads, and we of course create a render states and pass it a pointer to our sky texture so that it knows what texture to use when drawing. And now inside of this, you can see we have got 4 different vertex arrays here, and each of these contains a actual vertex position. So first of all, the position, you can see the first vertex is at 0 0, the second vertex is at 0 and screen height, the third one is at screen width and screen height, and the fourth one is at screen width and 0. So this basically covers has 4 vertices that cover the entire screen, and the second argument in these represents the texture coordinates. Now why do we need those is because when our player looks around, we want the sky to scroll so that it looks like a realistic sky and does not look like just an image pasted on the game. So in order to add that, we calculate this x offset. We calculate it based on the player angle so that when the player looks around, the texture scrolls as well. But you can see that we multiply the player angle by a small amount. The reason is because we want the actual when we scroll, we want that to look the same as the way we are scrolling the world. So for that, dividing our screen width by the player's turn speed and multiplying that by the angle seem to give pretty good results to me. And of course, I'm going to open up my player.h, and I have moved the definition of player turn speed into the header file so that we can access it from render.cvp as well. And I have also, by the way, changed the screen width to a bit smaller value. It's now 960 by 540, so this gives us essentially 9.6, and then we multiply that by the player angle, and this gives us our texture's x coordinate. And if this x coordinate is negative, then we just add the size to it so that we basically wrap around. If it goes less than 0, then we just put it at the same offset ahead of 0. But you can see that instead of using if here, we use while. The reason is that if the x offset, even though this should not happen, but just in case that the x offset is very low, and that might be the case if the player has been looking left in the left direction for a while. So if the x offset is lower even than like negative texture size, then because if the if our x offset is less than the actual negative texture size, then adding that will still have our x offset be negative. So in order to make sure that it actually becomes positive, even if it's like multiple times lower than the sky texture, then we need to make sure that we use a while loop. So it will run the first try. If it is still less than 0 after the first addition, then we are going to add the same value again, so that we keep doing that, and this should work. So now let's go down here, and you can see that when we are defining the texture coordinates, for the y we just use 0, and the actual y size as appropriate. When we are using screen height here, we use y size, and when we are using 0 here, we use 0. And for the x, we use x offset instead of 0, and we just add to the x offset when we are using our textures size. So we just add this to the x offset, and that's basically all we need to do. And this way we get the correct texture coordinates, and our sky should render. So I'm going to go ahead and test this. So let me go ahead and open up the terminal, and I'm going to run make, and you can see this brings up our raycaster, and you can see that we are getting a sky rendered. And if I look around, the sky scrolls, which gives a pretty realistic and 3D effect. So with that, we have got our sky rendering working, and yeah, this is pretty awesome. We have got basically our whole thing done, and in the next video we'll see if we can add more features. And I've been thinking about making a map editor for this, so that we can edit our maps better, and kind of see a preview as well, so like a real-time editor. That would be pretty cool. So tell me your thoughts about that in the comment section. I'll see you in the next one. Make sure to like and subscribe as well, and share this video with other people. And